and a very good day, everyone. My name is Mohd Sanusi bin Sali. Matric number is S50746, and I am from the Bachelor of Applied Science Maritime Technology with honors. Today, I would like to present to you my assignment, which is Method of Non-Destructive Testing from the subject Ship Repair and Maintenance System MMT 3203. First of all, I would like to introduce to you what is NDT. NDT stands for Non-Destructive Testing. It refers to an array of inspection methods that allow inspectors to evaluate and correct data about a material, system, or a component without permanently altering it. NDT may be called as NDE, which is Non-Destructive Examination or Evaluation, and NDI, which is Non-Destructive Inspection. Theory. NDT consists of a variety of techniques that can also utilize to detect, characterize, or measure the presence of the damage mechanism. An example, corrosion or cracks. NDT can be performed during or after manufacture, or even on equipment that is in service. In manufacturing, NDT inspections determine if parts are fit for a desired function. In other words, parts are inspected to ensure they will last a certain amount of time or cycle before failure. The purpose of NDT is to inspect a component in a safe, reliable, and cost-effective manner without causing damage to the equipment. These non-destructive testing methods include Penetrant Testing, magnetic particle testing, radiography testing, and ultrasonic testing. The first method is the Penetrant Testing, also known as DPT. DPT, also called as Liquid Penetrant Inspection (LPI) or Penetrant Testing (PT), is one of the oldest and the simplest NDT methods, where its earliest version using corrosion and oil mixture. LPI is used to detect any surface-connected discontinuities such as cracks from fatigue, pinchings, and grinding, as well as fractures, porosity, incomplete fusion, and flaws in joints. The principle of operation of DPT is based upon capillary action, where low surface tension fluid penetrates into a clean and dry surface breaking discontinuities. Penetrant may be applied to the test component by dipping, spraying, or brushing. After adequate penetration time has been allowed, the excess penetrant is removed and the developer is applied. The developer helps to draw a penetrant out of the flow where an invisible indication becomes visible to the inspector. Testing is performed under ultraviolet or white light depending on the type of dye used, fluorescent or non-fluorescent. There are 6 working procedures of DPT, which is the pre-cleaning, then the application of the penetrant, after that excess penetrant removal, application of developer, inspection, and lastly post-cleaning. DPT also have advantages and disadvantages. The advantages are high density, small discontinuities can be detected, few material limitation, which is metallic and non-metallic, magnetic and non-magnetic, and conductive and non-conductive material may be inspected. While for disadvantages, only surface breaking defects can be detected. Only materials with a relative non-porous surface can be inspected. Pre-cleaning is critical since contaminants can mask defects, and so on. This is some of the example application in the ship repair process. Magnetic particle testing (MPT). MPT is a non-destructive inspection method that provides detection of linear flaws located at or near the surface of ferromagnetic materials. It is viewed primarily as a surface examination method. MPI is a very effective method for location, surface breaking, and slight subsurface defects such as cracking, pores, collapse, lack of sidewall fusion in welds, etc., and magnetic materials. The principal operation, there are many different techniques. The most versatile technique is using a 110-volt alternate current handheld electromagnetic yoke magnet, a white chip of pin as contrast background, and a magnetic ink composed of iron powder particle in a liquid carrier base. The area is magnetized with the yoke magnet in the event of the surface or slightly subsurface defect being present or the lines of magnetic force will deform around the defects. The working principle of the MPT: first, you have to induce a magnetic field in the specimen. Then, apply the magnetic particle to the specimen surface. Then, view the surface, looking for particle groupings that are caused by defects. Lastly, demagnetize and clean the specimens. There are advantages and disadvantages for MPT. The advantages are can find both surface and near subsurface defect, and some inspection formats are extremely portable and low cost. For disadvantages, the specimen must be ferromagnetic, for example, steel and cast iron. Post-cleaning and post-demagnetization is often necessary. This is an example of application in ship repair process. Radiography Testing, or RT. RT uses X-ray and gamma rays to produce a radiograph of a specimen showing any changes in thickness, defect, internal and external, and assembly details to ensure optimum quality in your operation. RT usually is suitable for testing welded joint that can be accessed from the side. With the exception of double wall signal image technique used on some pipe. Although this is a slow and expensive NDT method, it is a dependable way to detect porosity, inclusion, cracks, and void in the weld interiors. The principle of operation. The method is based on the same principle as medical radiography in a hospital. A piece of radiographic film is placed on the remote side of the material under inspection, and radiation is then transmitted through from one side of the material to the remote side where the radiographic film is placed. These RT also have advantages and limitations. The advantages is volumetric inspection can detect surface and subsurface flaws, while for the limitation, equipment can be bulky and heavy, and you also have a hazard of the radiation. This example of an application in ship repair process. Ultrasonic testing. Ultrasonic non-destructive testing, also known as ultrasonic NDT or simply UT. UT is a method of characterizing the thickness or internal structure of a test piece through the use of high-frequency sound wave. The frequencies or pitch used for ultrasonic testing are many times higher than the limit of human hearing, most commonly in the range from 500 kHz to 20 MHz. For the principle of operation, at the left side, a probe sends a sound wave into a test material. There are two indications, one from the initial pulse of the probe and the second due to the back or echo. At the right side, we can see a defect creates a third indication and simultaneously reduces the amplitude of the back wall indication. The working principle of UT. In UT, an ultrasonic transducer connected to a diagnostic machine is passed over the object being inspected. The transducer is typically separated from the test object by the couplant, such as oil or by water. As in immersion testing, there are two methods of receiving the ultrasound, which is waveform, reflection, and attenuation. For UT, they also have advantages and limitations. The advantages are access to only one side is required, there is no potential health hazard, and results are highly repeatable and reliable. For the limitation, UT requires a trained operator, ultrasonic thickness gauges are very expensive and require multiple setups. This is one of the examples of UT in the ship repair process. This is the list of references that I collect from the internet. That's all. Thank you.